Section 2.3, acceleration. Now things are really picking up. So the notion of acceleration comes from when you have a change in velocity along with the time interval over which that occurs. So here we have a fighter jet that has some initial velocity at some initial time. Both of those can be non-zero, it can be some value. And then if there's some acceleration that could be in the positive or the negative direction, here it's in the positive direction, then it has a different velocity at a different time. The velocity is changed. Now, to illustrate this, for acceleration, I like to think about comparing the 0 to 60 miles per hour rating for different vehicles. So for a Tesla, at least as of a few years ago, might have gotten even lower now, Tesla can go from 0 to 60 in 3.2 seconds. That's super fast. What about a big rig? How long does a big rig take? Any guesses? Big rig fully loaded takes 35 seconds, so 10 times longer. This is why you don't usually want to be in the lane that they're trying to get into when they're merging on the freeway, because it just takes longer to get up to speed. They're going to be going slower. So comparing these two, right, they're both able to go 60 miles per hour. It's not that they can't, that the big rig can't go fast. It just can't get going fast very fast. In other words, it can't accelerate as quickly. The Tesla has a much larger acceleration that it can change its velocity in a much smaller time interval. So they have the same change in velocity, but Tesla is able to do it in a smaller time interval, which is a lot more acceleration. So let's check out our definition of average acceleration. Average acceleration is the change in velocity divided by the change in time. So notice the velocity has a vector, an arrow over it. It's a vector, it has a direction. That means the acceleration also has a direction, has an arrow over it. So let's try this with an example. So a drag racer crosses the finish line and the driver deploys a parachute and applies the brakes to slow down. The driver begins to slow down at 9 seconds and the car's velocity is 28 meters per second. When it is 12 seconds, the velocity has been reduced to 13 meters per second. What is the average acceleration of the dragster? Now you'll notice there I didn't say the T naught and T and V naught and V, and oftentimes the problems leave those out. You have to fill that information in yourself. So it's here for the moment as sort of a guide so you can see those connecting points. Down the road, you'll need to identify that, oh, we're carrying that the driver starts to slow at this 9 seconds. That's my initial time. And then the later time is the 12 seconds. Similarly, the later velocity is the 13 meters per second versus the earlier velocity is 28 meters per second. And this initial velocity isn't the very beginning of the race before the car left or even the finish line. It's just the initial velocity at that 9 seconds time of interest. So if we use these 4 numbers that are given to us with the variables as assigned and plug them into our average acceleration equation, we'll find that we have 13 meters per second, our final velocity, minus our initial velocity of 28 meters per second. Notice we're going to get a negative sign here. We have a smaller number to minus a bigger number. In the denominator, it's 12 seconds minus 9 seconds because time continues to move forward. So this is usually positive. So this tells us our acceleration is negative. And if you do the math, it should come to 5, a negative 5. Incidentally, also the units here do matter. They are meters per second divided by seconds. So it's meters divided by seconds twice. This is our SI unit. Oh, that was pretty bad. For acceleration, so meters per second squared is our SI unit. All right, but what about this negative 5? What does it mean that the acceleration is negative? You might be tempted to think that it means that that's telling you that it's slowing down, and that's not necessarily true. It is sometimes true, like in this case, but not always. The negative sign tells us that the velocity the acceleration is in the opposite direction as the velocity, right? So the velocity is moving in this positive rightward direction. The acceleration is going opposite the velocity. So it is going towards the negative direction, towards the left. So this brings us to an important point that's a fairly subtle one. And that's what's on the next slide here. When the acceleration and the velocity have opposite directions, which to have opposite directions, they just have to have opposite signs, positive versus negative, the object slows down and is decelerating. So if the velocity is in the positive direction and the acceleration is in the negative direction, the object is going to have a lower and lower speed. So it goes down to, after 1 second, it's down to 23 meters per second because there's been -5 meters per second squared acting on it. So after 1 second, it's lost 5 meters per second. After 2 seconds, it's lost another 5 meters per second. Where the negative acceleration doesn't necessarily mean it's slowing down is we could imagine, what if our initial velocity is in the negative direction, right? If my car was initially headed in the negative direction and I have an acceleration that's also in that negative direction, that acceleration is going to be boosting it upward. So it's going to be traveling actually all the faster in the negative direction. Similarly, if I then had a positive acceleration, sorry, that yellow is kind of bright, positive acceleration with a negative initial velocity, my car could now be slowing down, right? It's trying to go in the negative direction and the acceleration's acting in the opposite direction. So that acceleration is going to slow it down. So focus on if the velocity and the acceleration are working together or working against each other. And that will tell you if your object of interest is speeding up or if it's slowing down.